computers being all around us and help us in every aspect of our lives, one could only wonder how they work. And in this video, we'll touch upon like a really small portion of that, which is how computers store numbers.
Takes Jesus Jones 1993 zeros and ones. Even if you don't know about them at all, guess what they sing about? Exactly. Probably computers, right? In fact, it was. We all know computers are dumb and they can only process things in zeros and ones. Those zeros and ones are what compose what we call binary number. Bi meaning two, we can use etymology and some deduction to realize that in this number system, we have two digits, which are zeros and ones. Now when people work with computers, all these walls of zeros and ones get really nauseating really quickly, and so to make it a little easier to the eyes, we created another system called hexadecimals, base 16 numbers. This system can be somewhat easier for humans to read because more possible digits means more information that can be stored with less spaces. Let's look at how we convert between each of them.
We can easily convert from decimal numbers to any other base numbers by simply dividing the decimal number by the base number that you're trying to convert it to. And make sure to leave remainders and integers. So let's see what I mean by this. Let's try and convert 138 in decimal to binary. So we start with 138, right? We divide it by 2 because binary is a base 2 number. So we get 69 R0. Now we keep the integer, we keep the remainder. We keep doing this. So divided by 2 is 34 R1. Divided by 2 is 17 R0. Divided by 2 is 8 R1. Divided by 2 is 4 R0. Divide that by 2 is 2 R0. And lastly, divided by 2 is 1 R0. So now we take these numbers, we write it this way. So we go 1 0 0 0 1 0 1 0. And this is the base 2 number for 138 in decimal. So now for hexadecimal, we do the exact same thing, however we divide by 16 instead because hexadecimal is base 16, right? Divided by 16 now, we get 8R10. We can no longer divide 8 by 16, so what we do is we just do this again, so 8 and 10. However, what's different here is that in the hexadecimal number system, 0 to 9 is the same as in decimal. However, 10 to 15 does not exist. Instead, 10 is A, 11 is B, C, D, E, and F. So as you can see, our number 810 is going to be 810, which is A, so 8A in hexadecimal is going to be equal to 138 in decimal.
In the binary number system, value of the first digit of the rightmost one has a weight of 1 or 2 to the power of 0. Then the subsequent ones to the left of the first digit has its value being an exponent of 2. Means the second digit will be 2, the third one is 4, and the fourth one is 8, and so on. By adding together all the decimal number values from right to left at the positions that are represented by A1, we get the answer. For hexadecimal to decimal, the only thing different is that the base, 2 and 16. So it will become 16 to the power of 0, 16 to the power of 1, and so on.
Now let's move on to converting binary to hexadecimal or hexadecimal to binary. And we'll use the same example, which is 138 from decimal, which is equal to 8A in hexadecimal. And let's start calculating.
Firstly, we create 4 spaces for each number and convert that into binary digits. A is equal to 10, so the binary of 10 is 1010 using the method of converting decimal to binary, and 8 is equal to 1000 in binary. Therefore, the binary number of 138 in decimal or 8A in hexadecimal is 10001010 in binary. But what if we want to do it the other way around by converting from binary to hexadecimal? Let's use 10001010 as an example. Firstly, we need to separate the binary digit into groups of 4 digits since one hexadecimal digit is composed of 4 binary digits. Then we will get 1000 and 1010, and we need to convert each to hexadecimal. By calculating using the power method, 1000 is 8 in hexadecimal and 1010 is 10 or A in hexadecimal. So we get 8A in hexadecimal.
So we finally have come to the conclusion. So we hope that this lesson has been enjoyable for you because it was for us. So using the method that we have taught you before, we are confident that you can convert the hexadecimal to binary and to decimal, and all the way around. Thank you very much for listening. So